Good morning, students. I am Sivadargara from ECE Department from CMOS of Technology Engineering. So today we are going to discuss the concepts of stick diagram. So let us say first what is stick diagram, how it is useful, and why we are going to study about the stick diagram. So as we are studying the VLSI, so in that we are going for the fabrication. So before going for the fabrication, we have to submit the layout for the fab city. So in this regard, first we have to discuss about the stick diagram. So from that, next we are going to draw the layout for that corresponding circuit. So stick diagram gives or conveys the information regarding the layer information, what different layers present in that circuit. Next, simply we will call the stick diagram as a cartoon of the layout. So in this, first we will see, so what are the different layers present, the basic layers. So here the basic layers present are diffusion layers. And next we have power supply rails, VDD and the ground, and the metal contacts, and polysilicon. So these are the different layers required for drawing the stick diagram. And also here the stick diagram will convey the layer information using the different color codes. So for example, here some colors we are going to use for conveying or representing the different layers. So like metal, for metal we use blue, and next contacts we go for the black color, and next polysilicon we use red, and green is used for N diffusion and yellow used for the P diffusion. These are the minimum basic required layers for constructing a stick diagram for corresponding circuit. So here I am going to represent the stick diagram for in CMOS inverter. So let us draw the CMOS inverter stick diagram. And before that, so here we are representing different layers. So if same layers are crossing with each other, so automatically there will be a connection, like contact will be present. If different layers, like one is a diffusion layer, another one is the metal contact, this metal. So if both are crossed with each other, so the metal is different layer and diffusion is the another different layer. So these are dissimilar layers. So if they are crossed with each other, there will be no contact. No contact is present. So if a contact is required, we have to assign that a contact. So for the contact, we use a circle for representing, and black color we are going to use. So this is the basic information required for drawing the stick diagram. So here we use color codes for representing different layers. So for drawing the stick diagram, first we have to draw the first circuit. Actual circuit is required. So inverter. So inverter means here we have one input and one output. If we apply in here, we apply the logic levels like logic 0 and logic 1. If input is logic 0, so the inverter is going to give logic 1. If input is logic 1, the inverter is going to give output as a logic 0. We can use the terms logic 0, logic 1, or 1, 0, or true or false. Anyone we can use. So let us now we use the term logic 0 and logic 1. So here inverter, we know the symbol for the inverter. So this is the basic symbol for inverter. So this is the inverter symbol. So which has one input, the inverter symbol. So this is the symbol. So it has input. So let that input is termed as A and one output, and output is termed as B. So A and B. A is input and B is the output. So now we are going to draw a CMOS inverter. CMOS requires both PMOS and NMOS. So PMOS is constructed in pull-up network and NMOS is constructed in the pull-down network. So here as we have one input, we require one PMOS and one NMOS. So this is the construction of CMOS inverter. So this is PMOS, which is in the pull-up network. So this is the symbol. We are going to use the symbol for representing the PMOS and NMOS. So this is the NMOS, which will be in the pull-down network. So this is two transistors. So here this input, this is gate, and this is source, and this is the drain of PMOS. So this is PMOS and this is NMOS. So here this is gate and this is source terminal and this is the drain terminal. Drain terminal are connected together and two gate terminals are connected together. So here we are going to apply the input. So here I have assigned a name as A. This is input. Input is A. And output we collect at the drain terminal. Here two drains are connected together. So this is the output. So let it is named as B. And source of PMOS is connected to VDD, power supply VDD. And source of NMOS is connected to ground. So this is the ground. So this is CMOS inverter circuit. So for this we have to draw the stick diagram. So for drawing the stick diagram, so first we see what are the different layers present here. So for example, I will show how transistor is formed. So this is red color, this is polysilicon. So for example, if you are going for NMOS, so PMOS is this polysilicon is crossed with NMOS. So this is a NMOS transistor. So this is a NMOS transistor. So if we require PMOS, so same we take, for example, horizontal line I am going to take PMOS, and vertical we require here yellow. So yellow. So P diffusion is crossed with polysilicon. So this is PMOS. So for example, you can observe, so here polysilicon I have taken vertical line, here I have taken the horizontal line. So anyway you can use both polysilicon and diffusion are crossed with each other, a transistor is formed. So these are the two different layers. So now here we require metal. So for that we require blue line. So first we will take the blue line. So this is the stick diagram. So blue, this is the blue color. And next this is for ground. So this is VDD, power supply, and this is ground. So blue color is used. So power supply rails are completed, and next here we require a PMOS. A PMOS transistor is required. So this is the PMOS. So how PMOS will be formed? We require one polysilicon and other one is the P diffusion. In different ways we can draw the circuit. So first let us take polysilicon. You can take polysilicon or you can take the P diffusion. Anyone we can take. So let us take yellow color. So this is P diffusion. This is P diffusion. And next here we require polysilicon. Red color we have to choose. So polysilicon is crossing with the P diffusion. Now the PMOS is formed. So green color we will take here. Green. So let us take green color. So this is green. So now red color. This is polysilicon. So polysilicon is crossed with each other. So we can extend this polysilicon, two layers. So this is the extension of the polysilicon for giving the input. And as this P diffusion and N diffusion are different metals, they are layers, we have to connect both by using a metal contact. So metal, will take one more metal. So this is the output. So let us join these yellow color and green. So this is yellow. Next this is the green. So two diffusions are connected together. So this is one way to draw. So now this is VDD and this is the ground and this is the polysilicon represented with the red color and this is the N diffusion. So here if you observe metal and P diffusion are different layers. So here we require a contact. So contact, representing a contact, we are going to use black color. A circle we have to represent here, which represents this is a contact. This is a contact. So here metal and N diffusion is there. So here also we require one metal contact. So black color we are going to use, and this is another contact. So black we have to use. So now we will represent, this is contact, this is contact, this is contact, and next this is polysilicon, or in simple we can call it as a poly. This is P diffusion, P diffusion, P diffusion, and next this is the N diffusion, N diffusion, N diffusion, and output, and this is the output. Output we have termed it as a B, and input, and here we will apply the input. Input is A. So one more thing we have to represent for CMOS, that is substrate connection we have to show. So substrate connection is indicated with a cross mark. So this is one cross mark. So this is substrate connection. substrate connection. So this is the stick diagram for a CMOS inverter, which consists of PMOS. PMOS is in the pull-up network and NMOS is in the pull-down network. This is P diffusion and this is the N diffusion. And for showing the separation between pull-up and pull-down network, we require a demarcation line. So this is the demarcation line. So for that we require yellow color. So yellow color we are going to use for representing the demarcation line, which shows the separation between pull-up and pull-down network. So this is the demarcation line. So above the demarcation line, everything is pull-up network, and below the demarcation line, we have the pull-down network. So as we know the operation, so for example here input, we apply A equal to 0. If input A equal to 0, PMOS is on, fully on, and this is off. So as NMOS is off, it offers a very low resistance, it acts as an open switch. So now output is connected towards this VDD. So output is charging to the VDD. So output goes to high and input is 0. Now if input equal to 1, now NMOS is on and PMOS will be off. So now PMOS will offer very high resistance and there is no path from output to VDD. As NMOS is on, it offers very low resistance and output terminal is connected to ground. So whatever output is there, that will be grounded. So output will be equal to 0. So if we apply input as 0, it is going to produce logic 1 as output, and if input is 1, it is going to produce output as a 0. This is the CMOS inverter operation. So similarly, if you require any other circuit stick diagram, first we have to represent the circuit. So from this we are going for the next layout level. So one more we will see, this is the CMOS inverter. So one more example we will see, that is we will go for the NAND gate. So now we will draw circuit for CMOS NAND gate. So CMOS NAND gate. So CMOS NAND gate. So first you see the symbol. So this is the symbol of NAND gate, which has two inputs, A and B, and C is the output. This is symbol of NAND gate. This is the symbol of NAND gate. So what is NAND gate? So NAND gate output equal to high when one of the input is a logic low. So if all inputs are high, output will be logic 0. So which is the inversion operation of the AND gate. So first we will construct the circuit of NAND gate using the CMOS. So here, so one basic thing we have to see. So here we have two inputs. So we require two PMOS and two NMOS. So how we are going to connect that PMOS and the NMOS? So in previous case we have only a single PMOS and a single NMOS transistor. So here we have two transistors. So for one input we require two transistors, one PMOS and one NMOS. So how we are going to connect that two transistors? So pull down network. First we will see pull up network. So pull up network. Pull up network means it is constructed using the PMOS. It is constructed using only PMOS if you are going for the CMOS. So here for AND operation, that is dot operation. So dot operation. Okay, now PMOS transistors. So for dot operation, PMOS transistors. PMOS transistors are connected in parallel. Are connected in parallel with each other. So for OR operation, this is dot operation, that is AND operation. So for OR operation, PMOS transistors are connected in a series. Are connected in a series. Similarly, NMOS. NMOS. Let us take another color. So for NMOS, completely opposite to the pull-up network. So dot operation, that is AND operation. So for AND operation, NMOS transistors, NMOS transistors connected in series. Connected in series. So for PMOS, which are connected in the parallel. So for plus, that is OR operation, NMOS are transistors connected in parallel. connected in parallel. Completely opposite. If NMOS is connected in series, PMOS should be connected in the parallel. So this concept is required for constructing any circuit using the CMOS. So dot operation means that is pull-up network. PMOS transistors are used. So their dot operation, that is AND operation, all are connected. For example, if you have three transistors should be connected in the parallel. For OR operation, pull-up network, that all n number of transistors should be connected in the series. So which is completely opposite for the NMOS. Dot means series and plus means here in the parallel. So now we will see the circuit for NAND gate. So let us draw first CMOS NAND gate. So this is the circuit where it requires two PMOS transistors are required and two NMOS transistors are required. So in pull-up network, so what is the operation here? C equal to A dot B bar. So dot means what we have to do, previously we have discussed. Dot means pull-up network that should be connected in a parallel. So PMOS transistors should be connected in a parallel with each other. So this is one PMOS and this is another PMOS. So let the inputs are, this is input A and this is another B. These two transistors are in a parallel with each other. And pull down portion for dot operation, NMOS should be connected in a series. So these two transistors are connected in a series. This is NMOS. This is ground. So let it be transistor A and this is B. So here we are going to collect the output. So this is the output. Output equal to C. C equal to A dot B bar. So total 4 transistors are required. Now for example, see the operation. For example, A equal to 0. A equal to 0 and B equal to 0. So A0, B0. A0 means PMOS is on and this PMOS will be on. These both are zeros. NMOS 2 transistors are off. So on output is connected to supply voltage. This is supply VDD. Okay, now VDD. So output is connected to VDD through on transistors A and B. So output will be pulled to high. When both inputs are 1, for example, this is 1 and this is also 1. So A equal to 1 and B equal to 1. So 2 PMOS are off and both these 2 transistors are on. So output is disconnected to VDD and output is connected to ground through the on transistors to NMOS transistors. So output will be pulled down to 0. So this is the operation. See, one of the input is 0, output will be high. See, if one of these two are zeros, for example, A equal to 0. A0 means NMOS will be off. So one transistor is off, one transistor is on. So one is acting as an open switch. There is no closed path from output to ground. So now we will see the stick diagram. So first we have to draw the power supply rails. So this is VDD. This is VDD. So next here we have 2 transistors. So the 2 transistors here. So first we go for P diffusion. So this is P diffusion. And next for connecting we require a metal. So this is the metal output. This is P diffusion for forming the PMOS. In pull up network, in pull down network we require N diffusions. For N diffusion we require green color. N diffusion, so N diffusion green color. So N diffusion. And for ground we require blue color. This is the ground. Power supply rail. So this is this blue color and this blue line are power supply rails. So now we form the transistor. So for that we require red color. So the polysilicon is crossing with the P diffusion. This is P transistor. And now polysilicon is crossing with the N diffusion, P diffusion, that is PMOS. Both transistors are in parallel with each other. So here NMOS are connected in series. So this is transistor A and this is transistor B. So here we have to apply the inputs. This is A, input A, this is B, A and this is P. And next, whenever polysilicon is crossing with the P diffusion, a transistor is formed. So transistor 1, 2, 3, 4. Total 4 transistors are there. And if two metals, different metals are in contact, so here metal and P diffusion are in contact, so we have to connect it with a contact. So two dissimilar layers, these two are two dissimilar layers, so we require a contact. So here we require one contact, so circle we have to use, and color is black color is used. So this is one contact. So when we have to use the contact, if two dissimilar layers are present, so here metal and this P diffusion, so here also we require one contact. So here this is N diffusion and this is the metal, so here also we require one contact, and this is also one contact. Why? This is P diffusion and this is the metal, and last one more contact is required for connecting for showing there is a connection between N diffusion and metal. So this is the contacts. These black circles are contacts. So these are contacts. Why contact is required? If two dissimilar or different layers are connected with each other, so that should be connected with a contact. That is black color we have to use. And next we have to show the substrate connection. So here a cross mark we have to show, and here one more cross mark we have to show. This is a substrate connection. Substrate connection. And we have discussed everything here. This is blue color, power supply rails. Power supply rail. Power supply rail. And next yellow. What is yellow? Yellow is P diffusion. And next green, N diffusion. This is N diffusion. And here is the polysilicon. Red colors all are polysilicon, or simply you can write it as a poly. And whatever is remaining here, and this is the output. Blue represents this is output. So output we have named it as a C. And one more thing is left, that is demarcation line we have to show. So demarcation line is a line which is going to show the separation between pull down and pull up network. So this yellow lines are demarcation line. Demarcation lines. So this is the stick diagram for CMOS NAND gate. Similarly, you can construct stick diagram for any other circuits. So this is the concept we have to use. So practice 1, that is CMOS NOR gate.